Dear friends, good evening to everyone and welcome to the program. Now today I am going to take another test and the name of that statistical technique is Friedman analysis of variance by rank. So say this is the name you will find in some of the books. In some of the books, you may also find a name like this. Somewhere the name will be Friedman one way analysis of variance by rank. Or sometime you may also find another name, and that name is the Friedman one way repeated measures analysis of variance by ranks. It is ranks, not ranks. And sometime in somewhere of the books, you may find another name, and the name is, you may have the Friedman two-way analysis of variance. But in fact, it is one way only. That in some of the books it is written two-way, but in reality it is one way only. So sometimes you may get different names. So you should be quite clear about this particular aspect. Now, I have already told you and considered many situations where you have the two groups, where you have the ranks, but here you will have minimum three groups and you will have the scores, the ranks. You will have the scores, you can convert it into the ranks, no problem. So here assumptions are, one of the assumption is that there should be three or more matched group. It is not independent group. They are the matched group, and it is one way repeated measures. It is one way repeated measures of ANOVA. What is the meaning of repeated measures? That you have one group, then you give the treatment, and then you assess it. The same group, you give another treatment and you assess it. The same group, you give another treatment and assess it. So it is being repeated. So the same group, you are giving treatment one and assessing. To the same group, you are giving another treatment, assessing. To the same group, you are giving another treatment and you are assessing. So minimum there must be three groups, and these are not the independent. It is only one group of people, and then another is that the group which you are selecting, the group is selected randomly from the population. That you have the population of class 5th students of government schools of Jaipur. So you can select people randomly and you can do it. That's what exactly the meaning of it. Then another is that there is no interaction between blocks and treatments. Blocks mean you have the student and then treatment, then student and treatment. So between these there is no interaction. Then another is, it is one group is measured on three or more occasions. You have one group, you give one treatment, assess, another treatment, assess, another treatment. So it is done multiple number of times. Then data should be at least on the ordinal scale. If the data are on interval scale or ratio scale, and the assumptions of one-way ANOVA is not met, then the data can be analyzed with the help of Friedman analysis of variance by rate. And another assumption is that the data may not be normally distributed. You need not to have the normal distribution. Now, these are some of the assumptions which you may like to keep in the mind. Now, let us take one title, and if suppose I say like this, a study of achievement in physics of class 11, students of public schools of anything you can say, Ajmer. And my objective can be to compare mean, rank, scores of achievement in physics of students taught through lecture method, discussion method, and seminar method. So you must have minimum 3 groups, 3 treatments, and you have only one group. The same group, you are teaching a particular topic in physics, and you are teaching with the help of a lecture method. Suppose that topic you can cover in 1 week, say 6 days. After 6 days, you administer the test, and then after that, you teach to the same group the same topic with the help of discussion method and for the same duration of time. Now, you again teach for 1 week, and at the end of the 1 week, you again administer the same test. Now, after that, the same group of students should be taught the same topic with the help of seminar method for 1 week. So you are teaching one particular topic for 1 week through lecture method and giving a test, then again teaching the same group with the help of discussion method and administering the same test, and the same group you are again teaching with the help of seminar method and you are administering the same one. It's a study of achievement in physics of class 11, student of public schools of Ajmer. No, my dear friend, if you want, then I can have little change in the title, a study of effect of methods of teaching on okay, we can make this change, no problem at all. Because it is an experimental study, so fine line. Thank you very much. Yes. Now understand, if you teach a particular topic with the help of lecture method, and then you administer a test. Now you are teaching the same topic once again through discussion method. That means the student might have understood certain things through the lecture method, and those which he could not understand or she could not understand may understand through discussion method. So the second will have the effect of the lecture method also. And the third one will also have the effect of the lecture method as well as the discussion method. This is the progressive, that's correct. So now I can write a hypothesis that there is no significant difference in mean rank score of achievement in physics of students taught through lecture method, discussion method, and seminar method. It is the one group, the same group. Yes, Sunil Gawande, it is the same group. And minimum treatments are 3. You can give 4 also, no problem. 5 also, no problem. So now, if this is the one, let us go to my SPSS. Now here, since I have the 3 treatment, one is lecture method, lecture dot method, then another is my discussion dot method, another is my seminar dot method. If you want to have one more, you can have one more, no problem at all. But minimum there should be 3. And now I have to put the scores. Suppose the maximum score is 30. So some students' score might be 8, 10, 7, 11, 9, 10, 7.5, 8.5, 9, 10, 11, 8, 7, 9. Suppose I have the 14 people. Now the same people, if you are teaching a topic for 1 week and administering a test, then the next day, the same topic you are teaching with the help of a discussion method, and you are giving the same test, then the scores might be something like this. Then after 1 week, you administer the same test, and now the same group, you again teach the same topic with the help of a seminar method, and now you administer the 2. So this is how you can have it. And now we go to analyze, and we go to non-parametric test. And then we go to K-related samples. Because here it is 2 related samples, but here it is K-related samples. So we go to the K-related samples. And I shift all these things on this side. On the right-hand side dialog box. Now here is the Friedman, and it is already highlighted. So I can say okay, and then you can see these are the mean ranks, and this is your chi-square value, and your chi-square value is significant at 0.01 level, because it is 0.000, then I can write 0.01. And degree of freedom 2. What is the meaning? The meaning is that the mean ranks of achievement in physics of the student taught through lecture method, discussion method, and seminar method, it differs significantly. So that means these methods, they have effect on the achievement in physics of students. So let me write the interpretation, and then we proceed and you start understanding. So here your lecture method, it is 1.07. Your discussion method is 1.93, and your seminar method is 3.0. And my chi-square value is 27.11, and it is significant, and DF is 2. So let us, so this is my objective, and here I can write that 4.20.0 method of teaching wise comparison of mean ranks of achievement in physics of students. Then I say the 20th. Okay, you can say 4.19, no problem. You want 19, all right. The 19th objective was to compare mean rank scores of achievement in physics of students taught through lecture method, discussion method, and seminar method. The data were analyzed with the help of Friedman, one way, ANOVA by ranks. And the results are given in table. It is 4.90. Table 4.19. So here, method of teaching. Here is lecture method. Here is discussion method. And here is seminar method. And here is your mean rank, and here the mean rank was 1.07 and here it was 1.93 and here it was 3.0 and here the chi-square value. And the chi-square value, that is 27.11. Now methods of teaching wise, mean rank and chi-square value of achievement in physics of students. I hope you have understood up to here. Now, from table 4.19, it can be seen that the chi-square value is 27.11, which is significant at 0.01 level with df equal to 2. Now, if you want, you can add one more column and here you can write a remark and you can say the P is less than 0.01. Now, it indicates that there is a significant difference in mean rank scores of achievement in physics of students taught through lecture method, discussion method, and seminar method separately. So it indicates that there is a significant difference in mean rank scores of achievement in physics of students taught through lecture method, discussion method, and seminar method separately. Thus, the null hypothesis that there is no significant, difference in mean rank scores of achievement in physics of students taught through lecture method, discussion method, and seminar method separately is rejected. Now, you have to now understand whether the mean rank score of students taught through lecture method is significantly lower or higher than that of a discussion method, and further your discussion method with the seminar and your lecture method with the seminar. Now, even if you don't do anything, still you know that in the lecture method, the mean rank is lower than that of discussion, and that is seminar method. And that means the students taught through these methods in this particular sequence, then in the last treatment, they are found to benefit more in comparison to the earlier two treatments. Now, when they are taught through the lecture method and the same topic, when they are taught through the discussion method, so that is why the discussion mean rank is higher than that of a lecture method. Because the same topic you are teaching with a different method, the content is the same, the people are the same. So whatever is their understanding on the basis of the lecture method, that cannot be wiped out. It is not possible. So therefore, you can say here that your lecture, your seminar method was the best method of, or seminar, through seminar method, the students benefited more because the same topic were taught earlier by two methods, and this is the third time they were listening to the same teacher, the same content, but method is different. This is one. Another is, if suppose you want, let us see. That I go to analyze, I go to non-parametric, and I go to two related samples. And suppose I have lecture method and I have discussion method. Let's say I compare lecture method and the seminar method, then discussion method and the seminar method. Now these are the three combinations which you can have. And you can have Wilcoxon, matched pair rank test. And you say, here is a result. So when you compare the discussion with the lecture method, the ranks improved because the positive is 12 and the mean rank is 6.50. And you can see the chi-square value. The chi-square, the Z value here is 3.08 and it is significant at 0.01 level. Now, when you compare the seminar method with the lecture method, then your positive ranks now increased and mean rank is this, negative mean rank and positive mean rank, and the value is significant. And seminar method and discussion method, again, you can see it here. So that means from here, it is very, very, very clear to you that your discussion method is more beneficial to the group than the lecture method or alone. And here, your seminar method is much better than the lecture method. And the reason may be because in the after lecture method, the same topic they taught through this discussion method and the same topic again they learn. So that is why it's bound to be there. So if you want now, you can use this and you can write. So let me take down these values and then I will write. So this is my discussion and lecture. Then seminar and lecture. And then is your seminar and discussion. And here my Z value is minus 3.081 and it is minus 3.344 and it is minus 3.337. This is significant 0.1 and this also 0.1 and this also. So see, even if you do not use this test, McNamara test, Wilcoxon, signed rank test, still the value, the decision will be the same, but it is statistical. which give you more confidence to say that which one is higher than another one. So I am not noted, and therefore let's proceed further. So I read is rejected. Now in order to know which method of teaching was significantly superior to other, the data were further analyzed with the help of Wilcoxon signed rank test, and the results are given in table. So now this table was, I think, 4.19. So I can say 4.20 now. And now let us see here. So table 4.20. So let us insert the table. And just try to see how it. Now here I say method of teaching. And here I say so here is my lecture method. Another is my discussion method. And another is my seminar. And here, if I say here discussion method, so lecture method and discussion method, and here if I say seminar method, let us see whether this table will work or not. And this I so if I say here is the I have the positive ranks, And here I have negative ranks. And here I write down the positive ranks are no, I think I can write down not this. Please just give me a second. Here I can write down the mean ranks. Yes, it is positive rank. And here the mean rank is 6.50. And I have negative rank, which is 0. And now in the seminar also, the positive ranks are 7.50 and negative ranks are 0. And here also your positive ranks are 7.50. I think it seems to be all right. That here method of teaching by mean rank scores of achievement in physics of students. And my dear friends, I have to write the Z value also. I can write the Z value, that is 3.081, and it is significant at 0.01 level. And here the Z value is, and this was minus. So here also it is minus. It is 3.344. And it is also significant. And we can write here also Z is equal to minus 3.737. And this also significant. Otherwise, I have to make 3 different tables. I say significant at 0. From table 4.208 it can be seen that the Z value for lecture and discussion methods is 3.081. H minus 3.081, which is significant at 0.01 level. It indicates that there is a significant difference in mean rank scores of achievement in physics. Achievement in physics of students taught through lecture method. So there is a significant difference in mean lecture method and discussion. The mean rank score of achievement in physics of students taught through lecture method is, you see what I am now writing. Is 1.07, which is significantly lower than the students taught through discussion method. So 1.07 is 1.07, which is significantly lower than, which is significantly lower than discussion method, where mean discussion method where mean rank score of achievement in physics of students is 1.97 or 1.93. What was it? It was 1.93. So it may be said that it may be said that students benefited significantly more from discussion method as compared to lecture method. Now I copy and paste the same thing and then make the changes. I'll say the Z value for lecture and seminar methods is minus 3.344. Is minus 3.4, which is significant at this level. It indicates that there is a significant difference in mean rank scores of achievement in physics of students taught through lecture method and seminar method. The mean rank scores of achievement in physics of students taught through lecture method is this, which is significantly lower than the seminar method, where the mean rank is 3.0. It may be said that the students benefited significantly more from the seminar method as compared to lecture method. And now, and here I should say wide table 4.20. So this is another way, right? Now, another, I copy and paste and make the changes. The Z value for discussion and lecture methods is 3.337, which is significant. It indicates that there is significant difference in mean rank scores of achievement in physics of students taught through discussion method and the seminar method. The mean rank scores of achievement in physics of students taught through discussion method is 1.93, which is significantly lower than the seminar method, where the mean rank score of achievement in physics today. It may be said the students benefited significantly more through the seminar method as compared to discussion method. So it may be said that seminar method was more beneficial was more beneficial for teaching to students. Next beneficial method of teaching was discussion method. Discussion method. Why? Lecture method was not very was not as beneficial as this seminar discussion, or not beneficial as right. And I hope you have understood. If the values are not significant, then it is perfectly compared. Because if the values are that all the three treatments given to the same group are found to be equally effective. So that means the carryover effect may not be there. But when the values are significant, then there might be a carry, and you can say one of the reasons of finding might be that there is a carryover effect from lecture to the seminar, and other point also you can write. So any question you want to ask, then as I have to go somewhere, so I will be closing it, and tomorrow I will meet at the same time, our usual time at 7:30. So any question you want to ask before I say? Yes, it is a related sample, means it is only one sample, and the same sample is given the three treatments in a particular sequence. Yes, you are right that the last is the more beneficial, and reason I have given. Yes, that is correct. Wilcoxon is here. You want to see the table or you want to see output. Do you want to see the table or output? SPSS. This is the SPSS. That if you want to see the process, I can tell you the process. You go to analyze, and then you go to non-parametric test, and then you go to weighted samples. And then that here you are comparing the lecture with the discussion. Comparing lecture with the seminar. So lecture with the discussion, lecture with the seminar, and discussion with the seminar. And this is the Wilcoxon. And I don't want anything here. So fine. So I say okay. And this becomes my value. That is what is the meaning of it. Okay. Any other question like to ask? And if it is clear to you, take another example where the value is not significant or there is no need. Do you want another example where the values are not significant or there is no need? Do you want? Yeah. All right, let me give one example. Let me give another example to you. Suppose there are people, they are doing exercises for, let us say, for 15 minutes. So it is 15 minutes. Okay, let us say exercise 1, exercise 2, exercise 3. Suppose I am taking only 3 exercises. If you want, I can take more also. In fact, McNamara is better than the chi-square. But both cannot be compared with the chi-square requires your nominal scale data and McNamara requires your ordinal scale data. So do you want one more or is it all right? Do you want one more group or is it all right? So useless, you people. So all right. Do you want one more? Now let's say I am putting the data here and say I am giving the physical exercise and I'm taking the weight. So let's say I'm just writing the weight of the people 50, 52, 51.5, 53, 20, 56, 57, 54, 55, 56.5, 54.5, 55, 56, 54, 55. Suppose these are the weights. They do physical exercise for 15 days. After 15 days, you take their weight and this is the weight you have got. Now, again they are doing the exercise. And it might be 15 here. It might be 51.5 here. It might be 51 here. It might be 53 here. It might be 55.5 here. It might be 56.5 here. It might be 54 here. It might be 55 here. It might be 55 here. It might be 53.5 here. And it might be 55 here. And it might be 55.5 here. And it might be 54 here. And it might be 55 here. It might be 50 here. It might be 50.6 here. It might be 50.9 here. It might be 52.9 here. It might be 55 here. It might be 55.8 here. It might be 53.9 here. It might be 54.8 here. It may be 54.9 here. 52.7 here. It might be 54.8 here. It might be 55. It might be 53.9. And it might be 54.9. The another exercise. Say it might be 49.9. It might be 50.5. It might be 50.8. It might be 52.8. It might be 54.9. It might be 56, 55.8. And it might be 53.85. And it might be 54.78. It might be 54.88. It might be 52.68. It may be 54.79. And it be 54.87. Okay. And it is 53.88. It might be 54.87. Suppose these are the values. Now I go to my non-parametric and I go to my K-related samples and I shift everything on this side. And here is a Friedman. I say, okay. Now you can see the value. Now you can see that here the chi-square has come out to be significant. Why? In the first exercise and second exercise, there is no difference. In the first and the third, there is no difference. But in the second and the third, there is a difference. And in the first and the fourth, there is a difference. So that means if you have like this, it may happen that somewhere it can be. Yes, Sunita, you can see the output is here in front of you. I have not logged. It is here, Friedman test. So if you want it to be not significant, because chi-square is 39.60 and it is significant. So if you want the value not to be significant, then maybe I have to change certain things. Okay, is it not visible? All right. Now, is it visible to you? Now, is it visible or not? So therefore, now you can see it here. And it is significant because the first and the last one. But if you want it to be not significant, let me change the values if I can and make it a non-significant, let's say. Suppose maybe I do it like this, it is 50. I do it like this. Say it is 51.90. Here I say 51.89. And here I say 51 point, maybe 89. 51.49, and say here it is 51 point, again 49, and here I say 51.48. Suppose here is 53, here is 2 point, say 98. 50, here it is say 55.98. It is say 55.97, and it is a 55.97. It is 56.99, and it is a 56.98, and if it is a 56.98. It is okay, and let us say it is 55, 54.99, and it is 54.98. 50, it is 50. So it is 56.49. It is 56.48, and it is 56.48. It is 54.48. It is 54.47, and it is 54.47. It is 55. It is 54.99, and if it is 54.98, 56. So 55.99. It is 55.98, and it is 55.98. 54, and it is 53.99, and it is 53.98. 55, and it is 54.98, and it is 54.98. Suppose it is this. So let us go here. And now you can see the value. Let us see once again. It is non-parametric and it is k-related, and it is this I say here. Now it is again significant, my dear friend. Anyway, I am unable to come with a value which is not significant until and unless I don't have the same value. So I think it is all right, you can have it, no problem at all. If you were to have only the 3 groups, then quite possible that the values I can still manipulate, but it has to be manipulated many a times. I think we have understood it, that's fine, nice. So, okay, so I have to go, as I have to go somewhere. So please excuse me for today. Tomorrow we meet at 7:30 in the evening, and I'll go ahead with another. So that tomorrow I'm going to take with you the Kendall's coefficient of concordance. This is for correlation, association. Kendall's coefficient of concordance, it is for association. So you should try to read it if you can and come, and then we will definitely have discussion and a exercise also, so you will understand it. But so this you can note it down, Kendall's coefficient of concordance. Keep learning.